Today we're doing lesson 5.4. That's module 5, lesson 4. And your learning goal today, I heard someone say, yes, finally, your learning goal is to be able to use multiplication to help you calculate volume. Okay, let's first talk about the problem of the day. Today, before we begin, we're going to practice something we've learned before, which is how to multiply fractions by drawing a diagram. So go ahead in your notebook and write multiply fractions, and then write down these 3 problems and draw a diagram to multiply each of these sentences. Okay, our first one is 1/3 times 1/4. So if I draw a square, and this represents 1, how many sections do I have to divide it into to show 1/4? 4. Okay, so I'm going to divide it into 4 equal sections, and I'm going to shade 1/4. In order to have a complete diagram, Arhan, what do I need to do?
You need to label it.
Label it as 1/4. Very good. Now, do we want that whole fourth? We only want what fraction of that fourth? 1/3 of it. So I'm going to divide the whole thing into 3 equal sections. I'm going to double shade 1/3 of it. Again, to be complete, I'm going to label it. Now, how many sections are double shaded? 1. Out of a total of how many sections now? So the answer is 1/12. So you don't need to write this down, but let's take a look at this figure right here. What's one way we could cut that figure into layers? Itai, come on up and show us. And I'm going to draw what you write.
Like that.
Ooh, okay. Like this, make these cuts here?
Yeah.
If I make those cuts there, how many layers do I have altogether? 3 layers. And how many cubes are in each layer?
4.
So I have 3 copies of 4 layers. So the volume is?
12 cubic centimeters.
12 cubic, whatever, cubic units. We don't know what the units are in this case, right? So when you don't know what the units are, you just write cubic units. Okay, very good. What about this next figure over here? What's one way we could cut this figure into layers? Alex, can you come up and show us?
You could cut it in half.
Oh, okay, so then like slice it down the middle like this?
Yeah.
Okay, how many layers would we have then?
2.
2. And then how many cubes are in each layer?
8.
So if we have 2 copies of 8 layers, how many cubes are used in this entire thing? 16. So what's the volume? 16 cubic units. Very good. So this reviews how we can cut different figures into layers different ways. Is this the only way to cut it into layers?
No.
When you cut it a different way into layers, what changes? Does the number of layers sometimes change? Does the number of cubes in each layer sometimes change? Yeah, it just depends on how you cut it. So that's why it's important to be able to draw the way you're cutting it so that you can closely examine how many layers there are and the number of cubes there are in each layer. Does that make sense? Nice. When we look at this figure, there's 3 dimensions. Doesn't that make sense because it's a 3D figure, a 3-dimensional figure? So how many dimensions should we have? 3. Okay. We're always going to call the one across the length. Okay? So I want you to show in your notebook that you write this. And we use a cursive L instead of a printing L. Why? Because printing L's sometimes look like the number 1. So to avoid any confusion, we do a cursive L. And what's the length of this figure? 3, because we can see that there are 3 cubes across. So go ahead and label that. We call the width or the depth. Width is another word for depth. So how many cubes deep is this figure? How many cubes deep? 2. Okay, so the width is 2. And the height, that's how tall the figure is. How many cubes high is it? 4. So the height is 4. Okay, so go ahead and label those 3 dimensions. Now let's review. What's one way we could cut this into layers? What's one way? Ella, come show us. So Ella's saying we could cut it into layers like this. 1, 2, 3. Right? Would we make 3 cuts to cut it like that? So how many layers do we have there?
4.
4 layers. Go ahead and make your chart too. How many cubes are in each layer? If I cut it like this, how many cubes are in each layer? Take a look at that top layer. How many cubes are there?
6.
6. Very good. So what's the volume? How many cubes are there altogether?
24.
24. Do you guys see how we multiplied the number of layers By the number of cubes in each layer to find the volume? Okay. I have not completed my illustration here. I need to write the number of cubes in each layer to have a completed diagram. So what number do I need to write? 6, 6, 6, 6. There you go. Okay, is that the only way to cut this diagram or this prism? No. So Kevin said we could cut it like this. If I transfer those red lines down here, I would get something like this. Right? How many cuts did I make? 2 cuts to make a total of how many layers? 3. Okay. Now if I look at this right-hand side layer over here, how many cubes are in each layer? 8. So I can label it like this. And I can write that there are 8 cubes in each layer. Before I could, in the blue example, I multiplied the number of layers by the number of cubes in each layer to find the volume. I can do that again. And what's the volume this time? It's the same, 24 cubic centimeters. So looking at what we learned yesterday, it seems that we can always multiply the number of layers by the number of cubes in each layer in order to find the volume. Yes? Doesn't that make sense? Because that tells you how many total cubes you used. Now, this brings us to the formula of volume. Let's all write down that volume is equal to the length times the width times the height. The reason this works is because when I multiply the length times the width, do I get the area? Or do I get the number of cubes in one layer? And then when I multiply it by the height, is that the number of layers? Very good. So remember, we're trying to multiply the number of cubes in one layer by the number of layers. It depends on how you slice it, right? In some ways, when we slice it, let's say we have a cube here. Okay? If I slice it like this, I am finding the area of one layer, or the number of cubes in one layer, would be the length times the width, wouldn't it? But if I slice it in a different way, let me draw another cube for you. If instead I slice it like this, the number of cubes in one layer would be found by multiplying the height by the length, right? And then the number of layers would be here, which would be the width. Do you see? Sometimes the area of one layer can be found by multiplying the length and the height, or the width and the height. But when it comes down to it, we're always multiplying the length times the width times the height to find the total number of cubes that are being used. Does that make sense? Very good. From doing this, we can see that the area of one layer is going to be the length times the width, right? Isn't that how you find area? Isn't that also the same number of cubes in one layer? So in this case, what's the area or the number of cubes in the bottom layer? It would be 5 times 2, which is equals 10. So if we know that there's 2 layers and there's 10 cubes in one layer, would I do 10 times 2 to find the volume? Isn't that doing length times width, which was the area, times the height, which is our formula? So what's the volume? 20 cubic centimeters. Does that make sense? And that proves that the volume is found by doing the length times the width times the height. You need to be able to explain how you know that is true. And I just explained it to you. Does that make sense? If you cannot explain using pictures, numbers, and words why that formula works, you cannot use that formula. Got it? So, to practice, turn to your partner, one person who's sitting near you, and explain to them why the formula for volume is length times width times height.